Hello Gators, let's connect infinite limits and vertical asymptotes and connect limits at infinity and horizontal asymptotes. An infinite limit as x approaches infinity means that if the values of the function f of x outgrow all positive bounds as x approaches a finite number, we say the limit as x approaches a of f of x is infinity. Let's look at this example, 1 over x squared. Now, we can see that as you approach 0 from the right-hand side, this will be a small positive value, and in the numerator it's always 1. Well, when you have a small dividing by a small number and the numerator isn't changing much, then you are going to infinity, which is what we see right here. So as we approach, it looks like the graph is getting larger, and of course that's what we're seeing right here as we get closer and closer to 0. If you approach 0 from the negative side, again, we have a small positive number. Even though we have negative values, it's being squared, so we still have a positive. It's 1 over a small positive, which again will be infinity. So this is infinity, and this limit will be equal to infinity as well. So the definition of a vertical asymptote is x is equal to a as a vertical asymptote of the graph for y equal to f of x if the limit as x approaches a from the right-hand side is plus or minus infinity, as x approaches a from the left-hand side of the function, it's plus or minus infinity. Let's get an example here. I have a rational function, and what I've done is I factored, and now I'm going to work with the reduced form. This is the one without a hole, and it'll just be easier when I substitute numbers. I would like to take a look at what's happening as x is close to 3 from the left-hand side. So I'm going to check out a number that's very close to 3 on the left-hand side, 2.999. And when I substitute that in to the g, I will have 0.999 when I put that number in, and when I put it in here, I'll get negative 0.001. Again, I'm dividing by a small negative number, and this in the numerator is really close to 1. So it looks like I am going to be the fraction is going to become very large and in a negative direction. So this will be negative infinity. Let me check out 3 from the right-hand side. So I'll check out a point like 3.001. I'll put that back into my g function, make it easy on myself. 1.001, all divided by 0.001. I have a small positive number in the denominator, and I'm very close to the number 1 here. So that is going to be a very large number, and it's in a positive direction, so that'll be infinity. We're going to do the same kind of thing. We're going to get a handle on things, we're going to take a look at x is equal to 3.001, and I can see that when I put 3.001 in the numerator, I'm going to get around a negative 2, and in the denominator I'm going to get 0.001. And again, this is a small positive number, so this direction will be negative infinity. Let's take a look at number 5. I notice this is a perfect square, and let me go ahead and I notice that if I get close to the limit as x goes to 1 from the right-hand side, I'll put numbers that are a little over 1 on here. I am going to get a positive number in the denominator, but it'll be small, a small positive number in the denominator. And in the numerator, I'll be getting close to the number negative 2. So this means when on the right-hand side, this is going to be close to negative infinity. If I take a look at x goes to 1 from the left-hand side, I'm still going to have a negative 2 in the numerator, and because this is a squaring idea, I'm still going to have a small positive number. So both the left hand and the right hand look like they're approaching negative infinity, and so I'll have a vertical asymptote at 1 there. I'd like you to try this problem and stop the screencast and I'll give you the answer. And the answer is infinity. The numerator gets close to the number 1 and the denominator is a small positive number. Let's review something about rational functions. I want you to notice that when the factor is the same in the numerator and denominator, that is an indication of a whole. And even vertical asymptotes have an even power, and they look like this. Evens mean the graph wants to go to infinity or negative infinity in the same direction, both of them. An odd vertical asymptote is like this one, and that's when at the asymptote the graph is going to positive infinity and the other side is negative infinity, or vice versa. Let's now take a look at finite limits as x goes to plus or minus infinity. We use infinity to describe the behavior of the function when the values in its domain or range outgrow all finite bounds. We say the limit of f as x approaches infinity. We mean we are moving to the right on the number line. And when we are approaching negative infinity, that means we are moving increasingly far to the left. So this is an example right here. X goes to infinity, we're moving to the right. And you can see as we follow the graph and follow this, it looks like it equals 0. And if we follow our x values to negative infinity, it looks like it is 0. Let's look at another example of a horizontal asymptote. And in this example right here, we want to take the limit of this function right here, and it looks like as x goes to infinity, it looks like we're getting values that are closer and closer to 1. And if we let x go to negative infinity and we follow the graph, it looks like these values, as we go to negative infinity, it looks like it wants to go to negative 1. And this is an example of a horizontal asymptote. Okay, in behavior model, for a rational function, if this is a polynomial and this is the highest term, and then there's terms afterwards, and then in the denominator, this is the highest term and there's terms afterwards, we want to take a look at where n is the degree of the numerator, that's the highest power, and d is the degree of the denominator, that's the highest power of the denominator. The n behavior model will be that term divided by the other term, okay? And the other terms are really not going to have as much an effect on n behavior. Remember that when the bases are the same, we can write it as this, n minus d. Well, when n minus d is, when they are equal to each other, this becomes a 0. And x to the 0 means that this is a over b. So f of x will approach a over b. So the horizontal asymptote is a over b. Now, if the degree in the denominator is larger than the degree of the numerator, this is going to be a negative value. And when that is a negative value, that means a negative exponent, which means that x is going to be in the denominator. So it'll be something like this, 1 over x to some power, whatever that power is. And when that happens, the denominator here is going to grow as x goes to positive infinity or negative infinity, which means this whole fraction gets closer and closer to 0. And when it gets closer and closer to 0, the a over b times 0 means that the function is getting close to 0. So the horizontal asymptote will be equal to y is equal to 0. When the larger degree is in the numerator, when this is the larger number, then it's growing and without bound. And that means there will be no horizontal asymptote because it doesn't want to follow a line. It just wants to keep growing and growing. Okay, let's practice some problems. And so I want to find the horizontal asymptotes, which means I want to look at x going to plus or minus infinity. I notice that the numerator degree is higher than the denominator degree, that means there are no horizontal asymptotes. It just wants to keep growing. It doesn't want to level off. Now here, as I look at the limit, I notice the degree of the numerator and the degree of the denominator are the same. And when they are the same, I just look at the coefficient a over b, and so the answer will be 1/3. Over here, I'm going to take a look at the degree here. It is smaller than the degree of the denominator. That means the denominator is dominating. It's growing very large, and when it grows very large, it's making the fraction very small, and so this will be 0. I should have put, yeah, over here equals 0, not over here. Okay, now this one, I really only need the first term. After I multiply it, the first term is x squared, and then there's some other terms over here. And then over here, when I multiply it out, this will be 16x squared and plus some other terms right here. And I really don't care about what they are. But I notice the degrees are the same. And when the degrees are the same, I just look at the coefficients, which is 1/16. Let's take a look at number 8. Again, we take a look at the largest power, and the largest power here will be 2x, and here. And now that I see the degrees are the same, I'll just look at the coefficients, and so that's 2/3. Over here, again, I went ahead and I found the highest power, and I simplified it. And over here, the degrees are the same. It's square and square, so this will be 2/3. Over here, this is the limit as x approaches infinity of -4, and then this is x, e to the 1 over x, but this x is going to be really large because it's growing. So this is a large number. When this is a large number, then this is getting close to 0. So this will be -4 e to the 0, which is -4, because e to the 0 is 1. This one, go ahead and rewrite it, and negative exponents can be written like this. Put them in the denominator. This is going to be a very large positive denominator. This is just 5, and so this will be getting close to 0. So the property of limits as x approaches plus or minus, if the denominator grows faster than the numerator, the limit as x approaches infinity will be 0. So the denominator is going faster than the numerator. If the numerator grows faster than the denominator, then x approaches infinity, the limit increase or decrease without bound. So we don't have a horizontal asymptote. If the numerator and denominator grow at the same rate, look for the limit of a non-zero constant. So just take a look at the constant, the coefficients of those highest power terms. All right, let's evaluate the limit when we have a trig in it. Okay, so as x goes to negative infinity, this is going to be a large negative number. So it's in the negative direction. As x goes to negative infinity, remember what sine looks like. Sine looks like this, but when we're going over to infinity, it just goes back and forth, up and down. And so this, the biggest it'll be is 1, the smallest it'll be is -1. What's happening is this is really dominating. It's becoming very big. So it doesn't matter whether it's positive or negative, because that domination of big number will make the whole fraction go to 0. Let's take a look at this limit. This right here is getting close to 0 because the denominator is growing very large. So this is getting close to cosine of 0, which means this will be -3. Again, the talk about the sign. Remember the sign, it looks like this. And as you go to infinity, it just keeps going back and forth. So this is a does not exist problem. We're not getting close to one particular number. This is dominating the whole product. It's getting very large positive number. And cosine, the biggest it can be is 1, or the smallest is -1. So this is going to dominate it, and the answer is does not exist because it's just getting so big. There's not going to be a horizontal asymptote.